All right, guys, let's go through our expressions and equations study guide. So first thing is properties. So our first property, you can see that the order did not change. The only thing that changed is where the parentheses are and what two numbers are inside of them. So this is our associative property, right? Remember, that's your love triangle, who they are associating with, and it's of addition, so A. Next one, the order did change, 973 and then 937. So this is commutative. Remember, when it changes the order, that's commutative property, and it is of addition, so C. Next one, we have 65 times 21 and then 21 times 65. Again, the order is changing, so commutative property D. Next one, 2 and then parentheses AB, and then 2A in parentheses and then B. The only thing changing here is not the order, but is what is inside the parentheses. This is, again, your love triangle, B, associative property. Next one is being multiplied by 0. So negative 12m times 0 equals 0. So remember, anytime you multiply something by 0, it will equal 0. This is your 0 property multiplication, H. Our next one here, we have our 5 being distributed in 5 times 6 minus 5 times 8. And that is our distributive property, G. Then it looks like our identity stayed the same. 1 times x is equal to x. So identity property multiplication, remember, that's anytime you multiply by 1, so F. And then our last one here, they're adding a 0 to keep the identity the same, which is E. Okay, let's identify our parts of our expressions. So coefficients, remember, coefficients are your co-pilots. That's the number that's being multiplied by the variable. So we've got 12 in this 12x, this 3 in the 3x, this is a negative 2. And then here, remember, every pilot has a co-pilot, so this has our invisible 1. It's a negative 1, though. Oopsies. Okay. Then our constants. Constants, remember, are the numbers that are by themselves. They do not have a variable. So this negative 10 and this positive 12. Then we've got our like terms. Remember, your like terms have to have the same last name, so same variable to the same exponent. So I've got 12x and 3x. Those two go together. We also have a negative 2y and negative y. Those go together. And remember that constants are also sets of like terms. So negative 10 and positive 12 go together as well. Now, using that same expression, we want to simplify it, so combine our like terms. So I'm going to train this one up. Choo-choo. So box my terms. I'm going to rearrange it using my commutative property to find my families. So I've got 12x plus 3x. There's my x family. Then I've got my y family, negative 2y minus y. Those two go together. And then our constants, negative 10 plus 12. Those go together. So 12 plus 3 is 15x. Negative 2 and a negative 1. When I add those, that's negative 3y. And then negative 10 plus 12 is it's positive 2, because that's 12 minus 10, which is 2. And there's our answer. All right, so this one, we're still going to combine like terms, but before we can do that, we have to distribute. So remember, hand out the tickets before you get on the train. So we have to do this 4/7 times k. That's a 1k, so 4/7 times 1 is 4/7. Keep the k. 4/7 times this negative 2, or minus 2, so 4/7 times 2 over 1. Remember, multiply straight across. So 4 times 2 is 8, 7 times 1 is 7, and 8/7 is equal to 1 1/7. It was a negative here, or a minus, so minus 1 1/7. And then don't forget to bring down this minus 4k. Now I can train it up and box my terms so that I can find my family. So I've got 4/7 k minus 4k. And then I also have my negative 1 and 1/7. To combine my k's, it's really like keep, change, change. I'm adding a positive and negative, so I'm going to subtract here. So 4 and 0/7 minus 4/7. I'm going to need to borrow here. So borrow from the 4 becomes a 3. Remember, 1 whole in this situation is equal to 7/7. So this 0 is becoming 7/7. And then I can subtract. So 7/7 minus 4/7 is 3/7. 3 minus 0 is 3. And then keep the sign of the larger number, which was this negative 4. So negative 3 and 3/7 minus 1 and 1/7. Oh, and don't forget your k. Whoopsies. All right, same idea for this one. I'm going to distribute first. So negative 4 times negative 3 is positive 12. X times x is x squared. Negative 4 times positive 2 is negative 8. Keep the x. And then don't forget to bring down this minus 6x. My families are already next to each other, so I'm just going to go ahead and put them together right here. So 12x squared. And then negative 8 plus a negative 6 is negative 14x. And that is our answer. Okay, for this one, we are going to find the GCF, so everything that's in common between our two terms, and pull it out so we can rewrite it as distributive. When I say everything that's in common, I mean the number, I mean the sign, I mean the variables. Anything that's in common, we have to pull out and put outside of our parentheses for distributive, and then whatever's left over, that's what goes inside the parentheses. So I always like to start with t-charts for my numbers. So I have 40 and 12. So 1 times 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 and 7 don't work, so I'm all done there. Then I've got 1 and 12, 2 and 6, 3 and 4, and I'm all done there. So my greatest common factor here is 4. So I know that that's what number I'm going to put on the outside of my parentheses. And then I have to think inside my parentheses, 4 times 10 is how I got to this 40. So 10. 4 times 3 is how I got to this 12. So 3. That takes care of my numbers. Then I can see my variables here. I've got a k squared and k. Those have a k in common. So I'm going to actually pull just one k out. That leaves me 1 left over here with the 10. And nothing left over here with the 3. So I get 4k on the outside, and then inside 10k plus 3. And remember, an easy way to kind of check yourself here is distribute it. So 4k times 10k is 40k squared. 4k times 3 is 12k, and that is what the original problem was. So I know that I did it right. As long as I pulled everything out that was in common, then I know I did it. Okay, let's look at the next one. So I'm going to start off with my t-charts for 32 and 16. So 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5, 6, 7, none of those work. Okay, 1 and 16, 2 and 8, 3 doesn't work, 4 and 4. So this time my greatest common factor is this 16. So I know I'm going to have 16 on the outside. And think about what numbers are going to go inside. So 16 and times 2 would be in here. And 16 times this 1 inside my parentheses. Then I look at my variables. Well, my variables, there are nothing in common, so this is going to be a 1p. So I'm actually just going to write it as p. You could leave it as 1p if you want. I'm just going to put p. And then the last thing I need to think about are these negatives. Since both of these are negatives, I can pull them both out. So that's what I need to do. So I'm going to make this negative 16 out here, which will leave this positive in here. So the way I always think about it here is this was really like keep, change, negative plus negative. I'm going to pull the negative 16 out and leave a positive 2 and leave a positive 1p. So that this is my final answer.